So the past few days we've been talking about long division and reviewing that from when we learned it back in grade school, and then extending it to dividing polynomials. Well, today we're going to look at a new method of dividing polynomials called synthetic division. So synthetic division is a bit different from long division in the fact that, for starters, if we see up here, number one, it doesn't use variables or exponents. And I'll show you how to write that here in a second. Next, it uses addition instead of subtraction. So let's jump right into this example to see what I'm talking about. So it says use synthetic division to divide x squared minus 10x plus 21 divided by x minus 7. So the first thing to note is our divisor here, x minus 7. To do synthetic division, it needs to be in the form x minus r. And in this instance it's x minus some number, so we can go ahead and perform the synthetic division. So we'll start off by just reading off our coefficients. So we have a 1x squared, a 10x, and a 21. So I'm just going to write those down. 1, negative 10, 21. Now, the first rule, it says no variables or exponents, so we're going to ignore those for now. Now, we're going to look at this x minus 7 here again. And I'm going to take this 7 here, since we're of the form x minus r, we're going to take r to be equal to 7 and write it in this little box up here. So it's off to the side away from the coefficients from the first polynomial. Now I'm going to go ahead and draw this line here. And this is where we're actually going to start our synthetic division. So with our first coefficient here, we're just going to drop it straight down. So we just translate it down, so it's 1 there. We're going to take our 7 here and multiply it by 1. So 7 times 1, we know, is just 7. And we're going to put it under the second coefficient of the negative 10. Now, what we're going to do is, with normal long division, we would subtract those numbers, but with synthetic division, we're going to add them. So we'll take negative 10 plus 7, and we know that that is negative 3. Now we're going to do the same thing. We're going to take our 7 here, but this time we're going to multiply it by negative 3. So 7 times negative 3, we know, is negative 21, and we're going to add these two numbers to each other. This 21 plus negative 21, which we know, is 0. So how we write our answer here, our quotient, is since we had an x squared polynomial that we were dividing, we're going to write this 1 as an x, and this 3 as just a negative 3. The last number here on the far right is our remainder. In this instance, it's 0, so we don't have to write anything. So our quotient here would be x minus 3. So that's how we would do synthetic division in this instance. And we could check our answer here to see if we got the right one. So let's go ahead and do that. We divided x minus 7. That was our divisor, and our quotient was x minus 3. So if we FOIL that out, we'll have x times x is x squared. We'll have x times negative 3 is negative 3x. Negative 7 times x is negative 7x. And negative 7 times negative 3 is plus 21. And then when we combine like terms, we get x squared minus 10x plus 21. And so we did indeed get the right answer to this. As a review, you could also check it again by doing long division. So I'll leave that up to you to do, just for some extra practice on long division and to convince yourself that this method does work. So Now we're going to look at another example here. I've left the two things to keep in mind up on the board, so that way we've got them going through our mind as we're doing this example. So we're going to use synthetic division to divide 4x squared minus x cubed plus 7 minus 2x. And this time we're going to divide that by x plus 2. So if you remember from the first example, we need this to be in the form of x minus r. But here we have a plus. So in order to make this of that form, I'm just going to rewrite this as x minus negative 2. Because if we were to actually try to solve this, we would, when you subtract your negative, you add a positive. So those two are equivalent. So in this instance, r is negative 2. So when you see that plus sign in between this term over here, just keep in mind that it's going to be negative 2. It's not what you'd expect it to be. So now we're going to look at this polynomial real quick. If you notice it's not in descending order. So in order to do synthetic division, we need to have our exponents in descending order. So we need them to be largest to smallest. So I'm just going to go ahead and do that real quick. So this then becomes negative x cubed, because that's the largest exponent we have there, plus 4x squared minus 2x plus 7, still divided by, I'm going to rewrite this as x minus negative 2. And here, if one of our terms had been a 0, we would still make sure to put a placeholder in, because just like in long division when we had a 0 and we did a placeholder, we'd still do that with synthetic division here. But since we don't have that 0, we don't have to worry about that. But now that we have everything all set up, we can go ahead and perform the synthetic division. So I'm going to put a 1 in front of here, and I'm going to write all our coefficients down. So we have negative 1, 4, negative 2, and 7. And then we already said our r was negative 2, so I'm going to draw this little box again, put our negative 2 in there, and then draw our line. So just like last time, the first thing we do, we drop the first coefficient down. We don't multiply yet, so we just have our negative 1. And now we'll take negative 2 and multiply it by negative 1. So negative 2 times negative 1 we know is 2. So we'll add these two terms together. So 4 plus 2 we know is 6. We'll take negative 2 times 6. Negative 2 times 6 is negative 12. We'll add these two terms together. So negative 2 minus 12 is negative 14. And then we'll take negative 2 times negative 14, and that is positive 28. So then we'll take 7 plus 28, and that will give us 35. So just like last time, we look at our polynomial that we started with. So we had an x cubed as our largest term. So the largest term of our answer here is going to be an x squared. So when I drop this down, we'll have negative 1x squared. Our 6 then becomes our x term. We've got negative 14 as our constant term. And in this instance, the number to the far right, we do have a remainder here. We can write it the same way that we did in long division. So I'll drop it down, plus 35, and we'll put it over what we divided by. So this x plus 2, we'll put it on the denominator of our remainder. So plus 35 over x plus 2. And here, since it's our answer, you don't have to worry about writing it as minus negative 2. You can just write it as x plus 2. And so this right here is the solution using synthetic division. So you could go ahead and factor or FOIL everything out again and double check it, or you could perform long division and double check it again. So last, I just want to leave you, if it will go to the next page, there we go, with a comparison of synthetic division versus long division. So synthetic division uses no variables or exponents. So when you're doing it, you shouldn't have any x squareds, any x, any y's, whatever you're doing. You shouldn't have any of those. While long division, you do keep the variables and exponents. So if you remember, it could be something like x plus 2 into x cubed, yada, 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 so on and so forth. So you do keep your variables and exponents with long division. With synthetic division, we did addition instead of subtraction. With long division, we were using subtraction instead of addition. With synthetic division, it only works if your divisor is of the form x minus r, so like x minus 7, x plus 3, things like that. Whereas long division, you could divide something that looks like, or you have a divisor of x squared plus 7x plus 11, something like that. So those are key signs that you could use synthetic division or signs that you have to use long division. And lastly, synthetic division uses this little box. So you'll put your r into here. So you'll put your r into there, and you'll have, numbers over here, whatever, things like that, and it's just your numbers, whereas long division uses the same method that we saw when we did numbers. So like, if it was just a number, something like that. If it was actually a polynomial, something like this. So they do look different as well. So that's something that's important to keep in mind when deciding if you should use synthetic division or long division.